Hi, my name is Ramon Rosado. I'm a software engineering undergraduate student at the University of Puerto Rico at Maya West, and I'm here to present to you my 8-week virtual summer research experience mentored by Professor Marcelo Steinberg. This project is titled Defining a Similarity Index to Improve Image Appropriateness Analysis by Association. Images are everywhere today and are an integral part of social media as an alternative way of communication. Because not all images are necessarily appropriate for publication, social media outlets have to rely on image recognition software to pre-process these images before approval. Image analysis takes a lot of computational power and time. This is because there are so many images to be analyzed. Therefore, we need to find a way to speed up this process. We propose the approach of associating given images with an existing database of images previously analyzed. If we found that the given image was previously analyzed, then we can make a decision to see if this image is appropriate or not based on the decision that we made to the previously analyzed image on the database. Our goal in this project is to develop a tool that will enable a quick association between images based solely on the object type and the number of instances of each type a given image contains. We introduce a similarity index that, when comparing two images, will allow us to determine their similarity based on our goals. Currently, there is not much work done in the area of comparing images based solely on the image object type it contains. We introduce the metric of similarity index S to define the closeness between images. The similarity index assigns a weight to each object type depending on the number of objects found for that type and the total number of objects in both images. We selected a random subset of 250 images from the COCO dataset, and for each image within our dataset, we created a list of distinct object types and quantities for each object by image. We then computed the similarity index pairwise between all images. Our results show that the similarity index seems to prioritize object classes that have a larger number of object instances within the images, giving these classes more weight in the calculation of the index. For example, a pair of images that contain the same number of objects or close enough, while that object type number also being large, are more likely to be defined as similar. From this experiment, we can conclude that our proposed similarity index formula can be effectively used to measure, detect, and group similar images based solely on their features, also known as object classes. Future work that can be done to this project includes generating a larger dataset to test our results and conclusions. This is because we only use 250 sample images, so we would like to try our findings in a larger environment of data. Future work also includes to explore the possibility of adapting the weights for images that do not contain any object type with a large number of object instances to test if and how the similarity index formula behaves and if it is still accurate in finding similar images. Some other future work is to aggregate object types into supertypes and recalculate. This will mean, for example, creating a class of vehicles that encompasses various objects like cars, buses, trucks, and then testing the similarity index in this new environment. We would also like to expand and compare our findings by using different object detection AI models. And finally, we would like to deploy a live demo of our system in a social network to see how it behaves in a real-world situation. And that is all from me. Thank you for your time.